Now, in this video, we are going to go through some 3 problems that deal with dissolution. So if you take an ionic compound and dissolve it in water, what does it become? So we are going to look at 3 examples. First, we already know that if you dissolve something, the ionic structure of that compound is going to break. So the compound will become different ions when you dissolve it in solution. So we have 3 specific examples that we are going to use just to display what we are saying. So first, we are going to look at an aqueous solution of aluminum chloride. If you dissolve aluminum chloride, what solution are you going to have, or what species are you going to have in solution? So I'll change the so first we need to know what ions are present in aluminum chloride. We know that aluminum chloride has aluminum. Aluminum is in group 3. Therefore, the ion present is aluminum 3 plus. Chlorine is in group 7. Therefore, the ion present is chloride ion. So these are the 2 ions present in aluminum chloride. Now, if you start with aluminum chloride, when forming ions, the subscripts will change. So when separating ions, subscripts change to become coefficients. For example, if you start with aluminum Cl3, now if you want to make ions, the ion we are going to make is aluminum 3 plus, and then we have this subscript here changes 3Cl minus. So it becomes the coefficient. So what we are saying is that aluminum chloride, aluminum there is only 1, chlorine or the chloride ions, there are 3 of them. So what we do is when forming ions, we just transfer this 3 and put it in front of the chloride ion. So this is what we have in ionic form of aluminum chloride. We have 1 aluminum, which is 3 plus, and we have 3 chloride ions, which are, we just change from subscripts to coefficient of the chloride ion. So what does this mean? It means if you start with aluminum chloride, you are going to end up with 1 aluminum plus 3 chloride ion. That's what you are going to end up with. You start with aluminum chloride, you end up with 1 aluminum 3 plus and 3 chloride ions. Now I'm getting rid of all the ink. So we are saying that if you start with aluminum chloride, so what you do is the subscript becomes, when forming ions, if you are showing the charges, the subscript becomes the coefficient. So you are going to show 3 plus, and then because we have the subscript here, you change it to coefficient, and this becomes aluminum 3 plus, then plus 3 Cl minus. Now, if we get rid of the middle part here, you start with aluminum, you end with aluminum 3 plus and 3 Cl minus. So now when making solution, you dissolve a solid in water. So it means you put S here. So you are dissolving a solid in water, you just put S, indicating that you have a solid. And then you are forming aqueous in solution. So you put AQ for this one and AQ for this one. So you can say that you have your dissolution equation. So what we have up there is a dissolution equation. So this is our dissolution equation. If you dissolve aluminum chloride, that's the equation that you have to show the dissolution of aluminum chloride. Let's go on and dissolve sodium phosphate. So for this, we know that sodium is in group 1. So the charge of sodium will be Na plus. Now, we know that the subscripts for ions, and before we go there, there are 2 ions in this compound. We have sodium ions and we have phosphate ions. Now, these are sodium ions, and this is a phosphate ion. So the phosphate ion has, if I write again this, I can show it like Na3 and PO4. If I put this in parentheses, the phosphate ion has a subscript of 1. So there's 1 phosphate ion in there. But there are 3 sodium ions. So what you are saying is this one changes to 3 sodium ions and 1 phosphate ion. At least we know the charge of the 3 sodium ions here, but we don't know the charge of this. So we just call it X. So we know the charge of the sodium. We have 3 of them. Each one is charged +1. But we don't know the charge of phosphate. So we just put X as the charge of phosphate now. Now, 3 sodium ions, 3 Na plus, have a total charge of 3 times 1, which is plus 3. So we have a total charge of plus 3 from the sodium ions because we have 3 of them. Which means to cancel plus 3, we need minus 3. To cancel plus 3, we need minus 3. So that tells us that the PO4 has a charge of negative 3. So instead of X, you are going to have PO4 3 negative. That's what it tells us. So if you know the charge of sodium, you can get the charge of the phosphate ion. So don't change the phosphate ion. The phosphate ion will always be PO4 with a charge here. Don't make it PO. This is not a phosphate ion. So I'll get rid of everything here. So I'm saying if you start from here, in between here you have 3 Na plus and 1 PO4 3 minus. That's what you have, which becomes 3 Na plus PO4 3 minus. So we don't put 1 in front of the coefficient. We don't put 1 in front of an equation. Now, if you get rid of this part, you are going to have Na 3 PO4 solid to give you 3 Na plus aqueous plus PO4 3 minus aqueous. So this is the dissolution. This is the dissolution equation for sodium phosphate. Now we have used the charge of sodium to tell us the charge of phosphate. As you can see, I haven't changed how the polyatomic ion looks. The polyatomic ion should not change. It is a PO4. So don't change it to PO2 or PO. It is always PO4. We start with PO4 here. We end with PO4 here. Let's look at a third compound. Mg HCO3 2. Now, based on the periodic table, Mg is in group 2. Therefore, the charge of Mg will be Mg 2 plus. So if we start Mg HCO3 2, if we start with that, in between we are going to have, there is one Mg, so Mg 2 plus, but then we see this subscript, the subscript needs to go in front. So we are going to have 2 HCO3. Now, we know that for the charge of Mg is 2 plus. Here we have 2 of them. We have 2 of the HCO3, which means each one of it has a charge of -1. So we just put -1 here. Because we need 2 of them, we need 2 of them to cancel the 2 plus of magnesium. So each one is contributing a -1. So 2 times 1, or 2 times, let me just so 2 times -1, it makes a -2. So what we are saying is +2, -2 give you 0. So we are saying the charge of magnesium is 2 plus, therefore the charge of each bicarbonate is a negative. This becomes Mg 2 plus 2 HCO3 negative. So what we are saying is this molecule or this compound will form Mg 2 plus aqueous and 2 HCO3 minus aqueous. But we are dissolving a solid. So we are dissolving solid magnesium bicarbonate to give us magnesium aqueous and 2 bicarbonate aqueous. Now, how do we show the hydration of something like aluminum chloride? First, we know that this one will give us 1 aluminum, so this is solid, 3 plus aqueous, and 3 of these aqueous. So if you are showing hydration, aluminum is your positive, and it will be surrounded by water, but the oxygens will be close to aluminum because aluminum is positively charged and the oxygen on water has a partial negative. So partial positive, partial negative. And we have 3 chlorines of them. We are going to have a chlorine here, another chlorine here, another chlorine here. So these three chlorines will be surrounded by water. But the hydrogens will be close to the chlorines. So the hydrogen will be close to chlorine because chlorine is negatively charged and the hydrogen are partial negative, partial positives. The same thing here. The hydrogen is close to the chlorine. You do the same thing here because we have three of them. So just showing that the hydrogens are close to the chlorine and the oxygens are close to the aluminum. If you to do the same thing with sodium phosphate, we know that sodium phosphate solid is going to dissolve to form three of these and one of these. So each sodium, there are three of them, will be surrounded by this water. So you just need to actually show the charge of sodium. We have three of them here. And the third sodium is somewhere here, also surrounded by water, but the oxygens are close to it. Then we have our PO3 minus, now close to the hydrogen. Because PO3 is negatively charged, the hydrogen will be close to it. So that's the hydration of sodium phosphate. So you can use this for your handout and we'll continue in class. Thank you.